So in this video, we're going to be looking at simplifying and multiplying radicals. That's exactly what it says. So the way I want you to use this video is to have the assignment in front of you, and when I say, like after a couple examples, when I say you should be able to do these problems, then I want you to pause the video and work on those problems. And then when you're done with them, go to the next set, or like watch the next part of the video and then go to the next set. So the first 6 problems, oh no, the first 8 problems? Yeah, the first 8 problems are going to be like examples 1 and 2. So here we have a radical expression, and the instructions are to simplify. And our goal is to write something as something squared, so we can cancel out the exponent and write it outside the radical. So we're going to take the numbers and we're going to try and write them as perfect squares. We're going to take the variables and try to write those as perfect squares, and then when we do get a perfect square, the exponents will cancel out with the radical, and we'll be able to take the number outside of the radical. So let's see what happens. First, let's break down 147. So 147. I know it's not divisible by 2. I'm going to try divisible by 3. And I just have, I just took in the calculator 147 divided by 3, and I get 49. And immediately I know that 49 is 7 times 7. So now, instead of writing 147, I have 7 times 7 times 3, which is 7 squared times 3. So I know that for part of my radical, look at this, so I would have, let's see, red. I have the radical, and instead of 147, I now have 7 squared times 3. And then I still need the variable. I still need to change the variable. So we still have to deal with the k. Well, I'm trying to write this as something squared, and since I know already that if you have k to the 4th, that's the same thing as k squared, right? When you have a power of powers, you multiply, and then it would go back to k to the 4th. So I can just rewrite it like this: k squared squared. And then I have just k squared squared, and then anything that has a exponent of 2, I can cancel out with the square root. And then that number or variable or whatever will go on the outside. So in this case, we have that 2 going away and that 2, the outermost 2, going away. So I have 7 on the outside. So it says any number or variable that has an exponent of 2 cancels with the radical and goes outside the radical. So we have the 7 on the outside of the radical, and we have the k squared on the outside of the radical. And anything that's left over just stays inside the radical. And we just have, the only thing on the inside would be 3. And so we leave it like that. And that's my answer. And so there we go. Anything left over stays inside the radical. And then you have that. So let's try another one real quick and see if we can let's see if we can do it. So again, we have a radical, and what do we do? Well, we take the number. Remember, we take the number and try and break it down into its factors. So I have 1, 9, 2. It's even, so I know I can divide it by 2. That's what I always try first if it's even. And that will give me 96. Whoops. 96. And then 96 is even, so I divide by 2, and that's 48. And then 6 times 8, I can do that in my head, and then this is 2 times 3. I'm just breaking it down as much as I can. 4 times 2, and 2 times 2. Okay, so instead of 192, I have 1, 2, 3, 4, 5, 6. So, whoops, 2 times 2. I have 2 to the 6th power, and then, right, the 3's left over, right, times 3. Okay, same idea as in the last So that's the same thing as 192. So it's 192. I can rewrite it like that, just from my factor tree. And then just the same way that, where was it? Here, k to the fourth could be written as k squared squared. 2 times 2 was 4. Well, in this case, 2 times 3 is 6. So if I had, instead of writing 2 to the 6th, I could rewrite this as 2 to the third squared, because the goal, and then times the 3. The goal, remember, where does it say? Goal is to write any numbers or variable as squares. Even though it has an exponent on the inside, like this, we already know when you have a power of powers, you multiply, and, well, that's just the same as 6. 3 times 2 is 6. So there's for the number, so I'll write the square root of 2 cubed squared times 3. So that's for that, and then the variable. Alright, now we have x to the third. Let's just write it like this. X to the third. Now, since it's to the third, I can't really do any trick like I did last time. I can't do like squared, because then that would give me to the fourth power. But what I can do is rewrite this as x squared times x to the 1, right? I'm trying to get that square there. So, I mean, if this has to happen, then this is the way I would do it. And now I do have a perfect square, even though this one's not. I just have the 1 left over. So I would have x squared times x to the 1, and then anything that has a square will cancel out with the radical and come outside. So I have, well, 2 to the third, that's going to be outside. Remember, that cancels out with the radical. 3 is left over on the inside. 3 and x is left on the inside. So we have that. And then remember, this cancels out and this goes on the outside. And so that's my answer, except for 2 to the third, that's 2 times 2 times 2, that's just 8. So it's 8x raised to, times 3x in the radical. So that's the answer there. Just a bit of a note, if you had, say, like, let's, for example, a short example, mini example. If you had, say, we'll do it in black, x to the 5th, if it was odd, this one would change to x to the 4th times 1, or sorry, x to the 1, and then this part we can rewrite. If it's even, we can always do this little trick. If we have an even exponent, we can always do this little trick, where you are multiplying it by 2 eventually. So this one would be 2 squared times x to the 1. And then if it was under the radical, that would go away, this would go outside, this would stay inside, if that was a radical. If you had like x to the 7th, again, that would just change to x to the 6th times x to the 1. Of course, that's x to the 7th. And then, since this is even, we can rewrite this as x to the 3rd squared, and then times x to the 1. So if this was under a radical, that would cancel out, this would go outside, and that would stay inside. So there's how you do that. Right now, you should be able to do 1 through 8. So good luck with that, and yeah, get that done.